Hi, I'm Rahul Arora from the University of Toronto. I'm going to talk about mid-air drawing of curves on 3D surfaces in virtual reality. This work is in collaboration with Current Sync. Drawing curves onto surfaces is a fundamental interaction for multiple computer graphics applications. The most common use cases are artistic, such as painting colors, but there are other applications for semantic purposes, such as interactive segmentation, and for guiding geometry processing algorithms. The most common way to achieve this today is via 2D interfaces on a desktop. Artists paint directly on the surface in a what you see is what you get manner. As the user draws with a pen or mouse, a ray is cast in the view direction, and its first point of intersection with the surface defines a point for the curve. As the user continues to move their mouse or pen, every sample generates a ray which intersects with the surface, thus defining a curve on the surface. But you can run into some challenges when drawing such curves. The first problem is that you can cross a contour which either abruptly ends the stroke or leads to a sudden jump as shown here. And if you want to draw a complex curve, you may need to change the view direction multiple times, zoom in or out, etc. The question we asked is, how can you do better in virtual reality? Using a three-dimensional interaction and visualization space, can we make this task easier? Here's a VR curve drawing technique used in current commercial software. Imagine that the VR controller is a spray paint can. That is, define a ray casting direction as some fixed direction in the controller's local coordinate system. Now you can squirt paint out of the nozzle to draw a curve. But this also has obvious problems. If you are far from the surface, slight controller rotation can suddenly change the projected point a lot. If you try to stay close to the surface, to be more precise, you can accidentally go through it, and then you're suddenly drawing on an occluded region. So now we're dealing with 6 degrees of freedom, and slight changes in the position or the rotation can change the projection drastically. And that's not good. The big issue with spray can and other existing projections that we discuss in the paper is that these are functions of the current system state only, which includes the current positions and orientations of the controller and the head. We are ignoring all historical states that can provide additional context. In our paper, we look at projections which use the minimal historical context, that is, just the most recently projected point in the current stroke. The approach we propose is called stroke mimicry. The motivating idea is very simple and intuitive. When conducting pilot studies to evaluate existing techniques, we observed that when executing the 3D stroke P, users would mimic the shape of their desired projected curve Q. So, given a 3D stroke P, we want to solve for a Q which looks similar to it. Looking at this locally, say we have solved for Qi-1 and we want to find Qi, we want the vector difference between the two to match the difference between Pi and Pi-1. For this, we look at this vector delta P and add it to Qi-1 to get the anchored point Ri. Notice that delta P is small, typically around a couple of millimeters. The reason is that it is the difference between the consecutive controller position samples returned by the tracking system, which works at over 50 Hz in modern VR hardware. This in turn means that Ri is very close to the surface M. So here we can simply find the point on M that is closest to Ri, and that defines Qi. Now we only need to control 3 degrees of freedom. The orientation of the controller is not utilized at all, so this is much easier for the user. Mimicry allows the creation of complex curves which would be difficult or impossible to achieve using existing techniques. We can use such curves to efficiently paint textures and for guiding geometry processing applications, for instance, to design tangent vector fields. In the future, it would be interesting to explore machine learning techniques for customizing the projection to fit the user's preferences. We have released the data collected in our study to help with this endeavor. We have also released the source code and a demo, so please take a look. Thank you all for your attention.